Why do specialized systems, with their advanced, tailored solutions, still fall prey to cyber attacks? This question has baffled many, but to unravel this mystery, we need to dive deep into the intricacies of specialized systems. Specialized systems, by their very nature, are designed with a razor-sharp focus on a specific task or industry. Think of them as the bespoke suits of the technology world, meticulously tailored to match the exact needs of a business or industry. They're found everywhere. In healthcare, where they manage patient records, in finance, where they handle transactions worth billions, and in manufacturing, where they ensure precision and efficiency. These systems represent the pinnacle of human ingenuity, combining cutting-edge technology with an intimate understanding of industry-specific needs. But, and it's a significant but, they are not invincible. Despite their sophistication and the meticulous design that goes into them, they remain susceptible to cyber threats. Why is that so? Well, for one, the very specialization that makes these systems so effective also makes them vulnerable. They are often built from the ground up, with unique architectures and protocols, which can introduce unforeseen security blind spots. Additionally, their bespoke nature often means they lack the wide user base and community support that more generic systems enjoy, leading to fewer eyes on potential vulnerabilities. Moreover, the stakes are high. Cybercriminals are attracted to these systems precisely because they are so crucial to the industries they serve. A successful attack can wreak havoc, leading to significant financial and reputational damage. So, as we journey through this digital landscape, it's crucial to remember that no system, no matter how specialized or sophisticated, is immune to cyber threats. It's a sobering reality, but one that we must face if we are to secure our digital future. To fully grasp the magnitude of this issue, let's delve into a real-world case study. Because sometimes, the best way to understand a problem is to see how it unfolds in the real world. Stay tuned, as we're about to take a deep dive into the murky waters of cyber threats. Remember Stuxnet, the malicious worm that caused havoc in Iran's nuclear facilities? Yes, the Stuxnet attack. It wasn't just any cyber attack. It was a sophisticated strike that targeted a very specific specialized system, Iran's nuclear program. The worm was designed to exploit weaknesses in the industrial control systems that governed Iran's uranium enrichment facilities. The attack was so precise that it didn't just cause random damage, it altered the speed of the centrifuges to cause them to self-destruct, while simultaneously feeding false information to the system operators. So how did Stuxnet manage this unprecedented feat? It exploited 4 zero-day vulnerabilities in Microsoft Windows, which allowed it to spread undetected. Once inside a system, it used 2 stolen digital certificates to camouflage itself as legitimate software. But the real ingenuity? It lay in its ability to target a specific model of programmable logic controller made by Siemens, used in Iran's nuclear facilities. The damage was significant. Approximately 1/5 of Iran's nuclear centrifuges were rendered unusable, setting the country's nuclear ambitions back by years. The implications, however, were far greater than physical damage. Stuxnet marked a new era in warfare, introducing the world to the potential of cyber weapons to disrupt critical infrastructure. Could the attack have been prevented or mitigated? Perhaps. If Iran's nuclear facilities had been isolated from the internet, the worm might not have found its way in. Regular updates and patching of software vulnerabilities could have also helped, but the most crucial lesson here is the need for robust security measures tailored to protect specialized systems. Stuxnet was a wake-up call for industries worldwide, highlighting the need for robust cyber defenses in specialized systems. This attack showed us that no system, no matter how specialized or isolated, is immune to a well-crafted cyber attack. It's a reminder that in the age of digital warfare, keeping our specialized systems secure is not just important, it's imperative. So, how can one protect these specialized systems from such sophisticated attacks? Well, let's start with the basics. Regular system updates are essential. These updates often include patches for known vulnerabilities, helping fortify your system against potential attacks. It's like reinforcing the walls of a castle. You wouldn't want to leave any cracks unattended, would you? Next up, encryption. This works like an invisible, unbreakable lock, safeguarding your data even if an intruder manages to sneak in. It's a must-have for any system, specialized or not. Then we have multi-factor authentication, or MFA for short. This is your system's personal bodyguard, demanding multiple proofs of identity before granting access. It's like a bouncer at a club, not letting anyone in without a valid ID. And let's not forget about employee training. Humans, believe it or not, are often the weakest link in cybersecurity. By educating your team on safe online practices, you're essentially equipping them with a personal shield against cyber attacks. But here's the key takeaway. A proactive approach to cybersecurity is crucial. It's not enough to simply react to threats as they occur. Instead, think of it like a game of chess. You need to anticipate your opponent's moves and plan your defense strategy accordingly. Implementing these measures can significantly reduce the risk of a cyber attack, but there's no such thing as a foolproof system. What have we learned from our deep dive into the vulnerabilities of specialized systems? In our journey, we've come to understand that specialized systems, such as industrial control systems, are complex and intrinsically different from traditional information technology systems. Their unique design and operation, while exceptional for specific tasks, expose them to unique security vulnerabilities. We've looked at the Stuxnet worm, a stark example of how these vulnerabilities can be exploited in the real world. This malicious software, specifically designed to target specialized systems, caused significant damage to Iran's nuclear program, highlighting the potential consequences of such breaches. But it's not all doom and gloom. We've explored various strategies for mitigating these vulnerabilities. From adopting a defense-in-depth approach to using intrusion detection systems, there are ways to protect these valuable assets. It's clear that cybersecurity is not a one-size-fits-all field. Each system, each network, each device requires a tailored approach. That's why understanding the intricacies of specialized systems is key. And let's not forget, these vulnerabilities aren't just a concern for the organizations that manage these systems. In a time when our world is so interconnected, a breach in one system can have ripple effects across the globe. In a world increasingly reliant on digital systems, understanding and addressing these vulnerabilities is not just a necessity, but a matter of global security.